Hi. Exam 2 review.
You don't sound very enthusiastic about it.
Yeah, I have to write the exam, solve the exam, solve it again, copy it, sit bored for 90 minutes, and then grade it, record the grades, walk around the classroom to return it.
Don't you call us to the front?
So,
To the front. You know that.
yeah, see, if we could fix this issue, I'd be more excited about exams. They're completely pointless. But in any effort, exam 2.
Didn't you write the exam already?
Chapter. No.
What? You have another
It's
house class, don't you?
it's Monday. Exam is Monday, so we have. All right. So chapters. 8 plus 9. For chapter 8, we said no 8 point. Was it 8.7 the one that uses the list? Or 8.6? Which one was the 8.7? Okay. And for chapter 9, 9.1 and 9.3 only. That's the deal. So I think you have about 10 sections, something like that. And now so 8 to 10 questions. That's going to be 85 to 90 minutes. Test is 100 points. I think this time is 13% of your grade. Lucky 13. And I think that's it for housekeeping. No graphing calculators. I mean, they're useless anyway. And yes.
So for chapter 8 is from 8.1 to 8.7.
No, 8.1 to 8.9 without 8.7.
Okay.
And I think that's it. So topics. What are the topics? First, I know this is not a concept from Calc 2, but holy nightmare USub. It's gonna be there for a lot of problems, right? So USub is something that you must know. And now we can start listing all of the other ones. By parts. Then we have the trig integrals, and then for trig sub, we have partial fraction, then we have the improper, and we have numerical integration, and that one breaks into midpoint, trapezoid, and Simpson. And then number 8, we have, I think that's it for chapter 8, right? Chapter 9, differential equation definitions, and number 9, separation of variables, and that's it. Now, given that we can combine these rules into the same problem, we can have an exam with like 3 problems and be done. With a single problem on differential equations with separation of variables, you have to classify it. Then do one of the numerical problems. and then just make up a problem that has the rest of the list in, and it's good enough. Right? I actually lost it, but I did have a problem. I could sit and create one, but yeah.
You mess it up, you just get 0. I think it's 0.
You give the normal quiz, and then one on the back is the mega problem, and you can do either or.
Yeah.
I think it's
For partial fraction, you set up a problem, right? You don't have to solve it.
There will be 2 problems, maybe. One is the full solution, that's definite, with the 2 or 3 variables. But the additional problem might be the one with just setting it up. And that one will have 6, 7, 8 variables, because you're just setting it up. You're not solving anything. So partial fraction decomposition, full problem, 2 or 3 vars, and then maybe set up 6 to 8 variables, 5 to 7 variables, 6 to 7, 6 to 8. I'm probably going to put 7. But if I say 7 and then I put 6, someone's going to scream at me. So, yeah, over prepared. Yes, in that case, I didn't have to study extra 12 seconds. It's just
I wasn't able to do the bare minimum.
yeah, you were not able to optimize. All right. In terms of the exam, everything is the same like last time, except this time you have more choices, more variables, right? Different types of integration. Last time you only had basic integrals and USub. Now in the mix is by parts and Trig Sub and all the other stuff. So important to remember, improper integrals can have any integration within them. Improper integrals deal with those limits that are infinite or vertical asymptotes, type 1, type 2. So be very careful with improper integrals. Any problem that has limits could be improper integral. It doesn't have to be, but from now on it could. So let's make it like that, to stand out, to be careful about it. Do you have any questions, problems to solve?
For the numerical integration, are you going to have just pick either midpoint trapezoid or Simpson, or are you going to have like 3 different questions for all of them?
In the past, it was use the trapezoid rule, use the Simpson rule, use either trapezoid or Simpson, use the midpoint rule, right? If it's specified, you use that method. If there's choice, you pick the method. I don't know. You have 3 formulas, right?
Yeah.
All of them have the same delta x formula, b minus a over n. And we know for Simpson, n must be even. So those are some of the rules. But you have the full definitions. Anything else? Solve some problems. We have differential equations, separation of variables. We have, now that can have whatever integral on either side. So separate the variables, and then you have a trig sub on one side, and then the integration by parts on the other. Yes?
Could we see the, I forget what you called it, but like for biparts where you have the special thing for biparts? Like,
Oh, yeah. That's the best answer I can give you.
all right.
Now you know what happens when someone gives you that answer. They definitely put it on the test, right? So. The best thing was at graduate school where a professor said there will be no Sturm Louisville transformation on the exam. Like, yes, that's a 3-hour derivation problem that we did in class, which you can just memorize a couple of lines, right? Problem number 2 on exam 2. Use the Sturm-Liouville transformation to go. Like, great. Awesome. Didn't even look at it. And in class, he also said, you know, it's at least you can see this once in your lifetime. You go through this calculation, you know. It
was actually twice.
I generally try to stay away from secant cubed, you know. Any problems to solve? Yes, problems to solve.
Partial fraction.
Okay.
There's one.
Let's see what you got. Well, you can read it. It's okay. The part integral of what?
Partial fraction. Numerator is 2x squared plus 17x plus 20
You're killing me over here.
over x parenthesis x minus 5 close parenthesis 5x minus 4.
Dx. Good. Okay, partial fraction decomposition. This one has 3 linear terms. We are looking in to have a over x plus b over x minus 5 and plus c over x minus 4. So this is going to be now integral. Oh no, I was just going to solve this. So a times, so we have to foil these and then multiply them into a. So x squared minus 9ax plus 20a, and then b is gonna go plus bx squared minus 4bx, and then c is going to multiply the other two plus cx squared minus 5cx. Great. So now we collect x squares, we collect x's, and we collect constants. So a plus b plus c equals to 2. Minus 9a minus 4b minus 5c is equal to 17. So those are x's. 20a is equal, that's the only one with a constant, everything else has x's, is equal to 20. So this would be considered actually easy problem for the test, because it is 3 variable problem, but as you can see, you instantly have a is 1. So that's why it's considered very easy, because instantly it turns into 2 by 2 system. So now I have b plus c, because a is 1, is equal to 1, and negative 4b minus 5c is equal to 17 plus 9 is 26. Multiply the top one by 4 and add. So b's die. We have negative c is equal to 30. So c equals to negative 30. One more time. B times 4 cancels. 4c minus 5c is minus c. And 4 plus 26 is 30. Usually you forget to multiply this, and then the problem goes to hell. So make sure you are multiplying the constants on the other side as well. Okay, so now I have that. So a is 1. B is unknown. minus 30 equals to 2. So that's 32, 31. B equals to 31. I'm not boxing any one of these because that's not the answer. I still have to integrate. So I have integral a over x. A is 1. So 1 over x. Don't forget the parenthesis because you're going to have 3 separate terms to integrate and they all need to be times dx. So parenthesis is important. Plus 31 over x minus 5, if I remember. Yep. And then minus 30 over x minus 4 dx. So now integrate all of these. If you don't know them by heart, then you have to do USub, but by this time you should know that when you have a number divided by the linear term, it's just ln. Plus 31 ln x minus 5 minus 30 ln of x minus 4 absolute value plus constant c, and that's the end of the problem.
My math lab will tell you you're wrong.
My math lab, yeah.
Is maybe do another problem, please.
Yes, let me just say, so is this clear? Okay, cool. So this is a problem which had 3 linear terms, which is why, right, each one of these was a single variable. Cool. Yes, what do you got?
The integral of tan squared x times secant cubed x dx.
So secant trying to see if this is going to fit any of the U substitutions, because you are not supposed to memorize those reduction formulas. If this has to use a reduction formula, then you don't have to worry about it. You know that they have the reduction formulas in the book?
The power reduction?
Yeah, for secant and tangent. So if you have to use that to solve the problem, then the problem is too crazy. I'm now looking at the derivative of tangent x is secant squared x. Not happy because I have secant cubed, right? And I can't get the single secant into tangents, so that's a problem. And the second one, d dx of secant x is secant x tangent x. So if I peel one of these, I have 2 secants, which is good, but then I have a single tangent and I can't change that one. So the basic USub doesn't work on this problem at all, either way you look at it. So if the integration by parts doesn't work, then we're not going to have something like this, because it has to use those formulas and that will be too crazy. Okay? Make sense? So now I'm going to try. So the first thing I try the basic U substitution, which is given through the basic derivatives. And I already determined that neither of those works. Why? In order for me to have the top one work, I need to keep secant squared in a bank, and then the rest all must be tangents. So if I peel off secant squared x for dx, I'm left with tangent squared x single secant x, and I can't convert single secant into tangents, and that's the reason why the first one doesn't work. The second one, I have to keep secant x tangent x in a bank. So if I peel off secant x tangent x in a bank for du, then what's left for me is tangent x secant squared x. Well, I can only have secants, and I can't transfer single tangent into secants. So again, the basic USub doesn't work, doesn't apply. So now we can only hope that integration by parts would work. And if that doesn't work, then we're not going to have those formulas, right? So that's it. So what can I integrate? Well, I can integrate secant squared. So if I go u equals tangent squared x times secant x, and dv to be secant squared x, and then now du is going to be we can change tangent square into secant square by secant square minus 1. So u can be secant x secant squared x minus 1. So u can be secant cubed x minus secant x. And the v, I didn't do the du yet. So du is integral of secant cubed is 3 secant squared x. The derivative of secant is secant tangent x tangent x minus secant x tangent x, and this is just tangent x. This tends to be dx. Yeah, this is gonna, there's a dx here. The other way, change these ones into secant to the 5. How do you deal with secant to the 5? You don't. One would be secant cubed, the other one would be secant 5. Yeah, definitely. This one has a secant cubed on its own as well. If you change tangents into secants. Yeah, this is way too spicy for the test without the reduction formulas. So you can use the formula that it's in the book, which is secant to the m, tangent to the m, and then solve this because that's what they exist, right? But to actually figure that out on your own for random exponents like this, it's so can you expect a problem like this? Yeah, but it's gonna be a cube over here. In that case, it's easy. All right.
So you could change one of the tangent squares to
secant, and you keep the other tangent in a bank, right? And then you can, yeah. So yeah, this is too spicy. Anything else? Yes.
Can you actually go over it if the tan was to a cube?
If we have a cube, okay. So if it's a cube, then we keep secant tangent in the bank. So I'll have tangent squared x, secant squared x, and then secant x tangent x dx will keep that in a bank. Now I see that my substitution must be secants, so these tangents have to be transformed. So the tangent is secant squared x minus 1. So now what I have is integral of secant squared x minus 1 times secant squared x times secant x tangent x dx. Now you distribute and you get secant to the 4x minus secant squared x times secant x tangent x dx. And now you have the basic u sub. U equals secant x, du equal secant x tangent x dx, and the whole problem collapses into u to the 4 minus u squared du, which becomes u to the 5 over 5 minus u cubed over cube plus c. And now it's 1/5 secant to the 5x minus 1/3 secant cubed x plus c. Happy? Yay. Anything else?
The PQ problem, du dx equals 6 e to the 7x minus u.
Du dx equals
6 e to the 7x minus u.
like this?
No, 7, the u's up to the e also. Yeah.
Like this? Oh, good. Because if that was downstairs, it can't be done. But now it can. What does it mean when you have subtraction?
And just multiple. It's
Yes.
7x multiplied by negative.
Awesome, right? So now we separate the variables. We get e to the u du is equal to 6e to the 7x dx. Hit both sides with the integral. We get e to the u du, e to the u equals 6 over 7e 7x plus c. Now we need to solve for u, so we can ln both sides, and we get that u is equal to ln of 6 over 7e to the 7x plus c. Ta-da! Anything else?
It's calm.
Anything else? Come on, where's the trig sub? Where is the improper? Where is the... Come on, hit me. Yeah, I'm concerned when you ask a question. Yes.
It's the integral from. Sorry. The integral from in the numerator, the root of square root of 9 minus x squared, and in the denominator x. What do you got?
This?
Yeah.
Does it have limits? No limits, right?
No.
Okay. Cool. This is definitely trig sub. If this x was upstairs in the numerator, USub. If this was completely flipped, if you flip it, USub. If you put x on the top, USub. Only in this configuration, trig sub, right? Can you do all three configurations trig sub? Yes. But anytime when you have x on top and x squared anywhere else, it's going to be USub. But x has to be on top for du. But now we have x in the bottom, and it's like, oh. So let's go. Trig sub. Who's excited? Like, apparently only me. All right, fine. We draw our triangle, right? The first number is 9. Square root of that is 3. Because it's a minus, it has to be hypotenuse. We're going to put x over here, and our square root 9 minus x squared there. If you don't like it, switch it. X and square root can swap the places, if this is your theta here. Now we're going to have the blue and the red pair. The blue pair is cosine. Cosine theta is x over 3.
Isn't it sine?
That's what I said. I'm just checking if you're paying attention. Very good. X equals 3 sine theta, and immediately dx is 3 cosine theta d theta. Good. The red pair is the cosine, again, theta, which is square root of 9 minus x squared divided by 3. We solve for the square root because that's what we have to swap. 3 cosine theta. Now we go and swap everything. Square root is 3 cosine theta. X is 3 sine theta. And dx is 3 cosine theta d theta. 3's are cancelled. And that's it. So now I have 3 integral of cosine squared theta over sine theta d theta. Cool. We use trig identity to write cosine as 1 minus sine squared theta divided by sine theta d theta, and that breaks into 2 separate right integrals. So 1 over sine is going to be cosecant theta, and then minus sine theta d theta. The integral of cosecant theta is ln of cosecant theta plus cotangent theta.
And there's minus negative sign from.
Yes, won't erase. I need to put the absolute value here. There we go. And minus integral of sine is negative cos is positive. No, integral of sine is negative cosine, so minus and minus gives you plus. So cosine theta and plus c. No, we're not done.
Just a question.
Yes.
On the cosine squared theta over sine theta part,
Cosine squared theta over sine theta, yes.
could you make cosine over sine
Cotangent times cosine?
and then
They're not pair.
cotangent cosecant, and then you could integrate that into cosecant, a negative cosecant?
If you make cosine over sine into a cotangent theta, all you have left is times cosine theta. So you want to make cotangent theta divided by secant theta. Yeah, it doesn't work because it's not. They're not pairs. So now we have 3 times negative ln. Cosecant is 1 over sine, so 3 over x. Plus cotangent is adjacent over opposite, which is root over x. Plus cosine theta, we already know, is square root over 3. And then plus c. Now you multiply the 3 in, becomes negative 3 ln of 3 plus square root of 9 minus x squared over x plus square root of 9 minus x squared plus c. Because the 3, I will cancel the denominator. This 3 has to multiply into ln and into this term. So it will cancel the 3 in the denominator. And we have this. Can you go more? Yeah, you can put negative 3 exponent, then the negative would flip this, the 3 would apply to each one. But that's all flexing. It's good enough. Anything else? We have the improper. We haven't dealt with improper. We haven't dealt with numerics. And we haven't done by parts a problem. So those are the 3 that we haven't talked about. We did diffq, we did. Yeah.
Can we do improper?
Of course. Which one? I mean, I don't know until I see it. Could be something diabolical where you have to use the formula number 87 from the list at the back of the integrals. Like, I don't really remember what the formula 87 is. You're memorizing all 108, right? The whole list.
Yeah.
Everyone has the sheet that I distributed for sequences and series? I mean for series? All good? Professor Chris, how's it going? Did you get it?
Try.
You try.
Okay.
All right. Get hyped. We're gonna get improper. That's it.
Okay. Ready?
Yes?
Integral negative infinity to infinity.
Integral negative infinity to infinity. I like the sound of that already.
Dx over x squared plus 2x plus 5.
Whoo. Whoo.
I can pick one
You
less spicy. Less spicy if you want.
No. This is perfect. Lock the doors. Because security will try to kick us out at 10, but we won't be done because what type of... It's improper, sure. We see infinities, blah, blah. What is the inside of the integral?
Arctan?
Arctan?
Yeah.
Complete the square.
Complete the square into arctan.
Yeah.
But if you can factor, it's not arctan, right? So when you have this, it's either complete the square into arctangent or factor into partial fractions. Write it down. So when you have polynomial like this, right, quadratic in the denominator, it's either partial fraction decomposition if you can factor. If you can't factor, then it's going to be completing the square. Now, completing the square, if it doesn't line up with the arctan, then it's a trig sub, right? If we already know it's, then we're good. All right, so let's see. Can we factor this one? And the answer is no. The only one that can factor is x squared plus 2x plus 1. We have plus 5. So can't factor.
So can you say that one more time? If it is factorable, then what?
If it's factorable, then you are going to end up with factors, which means partial fraction decomposition. Okay. Because we can't factor, and you always check factoring first, because that's faster than cranking the whole, completing the square. So now, we must complete the square. Okay, we do that by x squared plus 2x plus 1 plus 4. Right, we peel off the 1. These guys compress into x plus 1 squared, and then we have 4. Okay, the next question is, can we make this 0 somehow? And the answer is no. And that is, because no matter which x you pick, you will always add 1. And when you square it, it will always be positive, and then you will add 4. So the denominator is always bigger than 5, because if you pick x to be 0, then you have 1 squared plus 4, that's 5. So since the denominator can never be less than 5, we are guaranteed not to have asymptotes, and that means we don't have type 2. We only have type 1. If you had partial fraction decomposition with let's say 2, x minus 2, x plus 1, you would have 2 vertical asymptotes. That would create 8 integrals immediately, right? So, we're lucky. So what we're going to have here is negative infinity, let's say, to 0, plus 0 to positive infinity. We need to break it somewhere. So what are my integrals? We have the limit of a goes to negative infinity, integral a to 0, of dx divided by x plus 1 squared plus 4, plus limit b goes to infinity of 0 to b of the same dx over x plus 1 squared plus 4. Now, I am going to write 2 formulas here. The entry level, the noob one, is dx over x squared plus a squared is 1 over a inverse tangent x over a plus c. Now, the boss level is f prime of x dx divided by f of x squared plus a squared is 1 over a inverse tangent of f over a plus c. Or maybe never. Imagine it. Well, what I did is I placed f prime in front of dx, and f prime dx, f of x squared plus a squared is 1 over a inverse tangent f of x over a. Ah, it finally exploded. So try to complete the problem. The projector is busy. Okay.
Gotta get into the login queue.
Yeah. Yeah, the login queue. There's only 30,000 to go, and you know, approximate time 5 hours.
It's 5 minutes, but it actually takes 5 hours.
I know. That's how technology distorts your concept of time. I used to, the first time I used the internet was dial-up thing, and you were buying hours. So you go and you buy 30 hours package, 50, 100 hours. Used to spend like 10 hours of internet in 5 minutes. It was like,
Come on, you just get the free AOL disk.
okay, projector is not found. That's good, because it was off. At least it's not busy. How can you exceed your vision? Sometimes they just put these slogans to just have words. Exceed your vision.
You gotta predict the future.
To see something before you see it, I mean,
That's how you become top tier.
oh. This is why stuff is always going to be awesome. You just restart it. Can you imagine if you can fix your kidneys this way? You just shut down and just reboot, and it's all good.
Turn it off and on again.
Yeah.
You can try it.
Yeah, that's why they have the bzz thing. So, all right, let's go. Limit a goes to negative infinity, and now we have to take our 1/2 inverse tangent of x plus 1 over 2 computed from a to 0 plus limit b goes to infinity 1/2 inverse tangent x plus 1 over 2 from 0 to b equals limit and all of these things 1/2. Good. So limit a goes to negative infinity. We can kick 1/2 outside, so we don't have to mess with it. So we have inverse tangent of 1/2 minus inverse tangent of a plus 1 over 2 plus 1/2 limit b goes to positive infinity of inverse tangent b plus 1 over 2 minus inverse tangent of 1/2. So now we have 1/2 for the entire problem, and we have inverse tangent of 1/2. Well, we don't know what that is, just leave it. And now I have inverse tangent of negative infinity. Inverse tangent of negative infinity is negative pi over 2. So plus pi over 2, because this will give a negative pi over 2, and this negative is positive. 1/2 is already outside, so plus. Now limit as go to infinity is going to be positive pi over 2. Awesome. And now I have minus tangent inverse of 1/2. Well, that's going to cancel, which they should. Remember, we broke it at 0, right? So you should always have the cancellation like that if you break it at a random point, because those should not give you contribution towards the area under the curve, because you just arbitrarily broke it somewhere where it shouldn't be broken, right? So I have pi over 2 as a total, so it converges to pi over 2, because pi over 2 plus pi over 2 is pi, and then over 2 in front, so pi over 2. Cool. Thank you. That was a problem, and we went through actually very important concept of trig versus partial fractions, right? Because it is a polynomial, right? So it was a polynomial. So that was cool. Anything else? Going once.
Office hours,
Going twice.
tomorrow, Friday, Saturday, Sunday.
Ow. It's on the syllabus. You know the rules. So,